This is Unit 1, Lesson 3 from the Absolute Value Equations and Inequalities unit. Today we're going to be working on solving absolute value equations and inequalities in one variable. By the end of the lesson, you should be able to solve an absolute value equation in one variable algebraically using compound inequalities. You should be able to graph on a number line an absolute value equation and an absolute value inequality. And you should be able to write an absolute value inequality in one variable from a given graph on a number line. All right, so we're going to start off by solving just some basic absolute value equations. Okay, so when we're solving an absolute value equation, we have the equation, the absolute value of a times x plus b is equal to c, where c is greater than 0. And it's equivalent to this compound statement. Oh, sorry, just having some technical difficulties. Okay, so it's equivalent to this compound statement. Ax plus b equals c, or ax plus b equals negative c. So when we're solving absolute value, okay, we're thinking of, remember, the absolute value is the distance to a certain point, and there's always two, okay? Just like when we think about the absolute value of negative 6 is equal to positive 6, and the absolute value of 6 is equal to positive 6. All right, so we're thinking of two different values here, so we have two different equations. Right, if you notice, one equation remains the same as the initial, and the other one has our c negated, okay? So that will always be our second equation. So to solve down here, we can set this up. We can say 4x plus 2 is equal to 6. Or 4x plus 2 is equal to negative 6. And we can solve both equations. So I subtract 2 from both sides, and I get 4x equals 4. Divide by 4, and I get x equals 1. Down here, I can subtract 2, and I get 4 times x equals negative 8. Divide by 4, and I get x equals negative 2. So I know that both 1 and negative 2 are possible solutions. Now it's important that we always plug our numbers back in and check them to see if they work, because no matter what, when you set up an equation and you solve it, you're going to get a value. You need to make sure it works for the problem. So we can do a quick mental check. If I plug 1 back in here, 4 times 1 is 4, plus 2 is 6, and the absolute value of 6 is 6, so that works. If I plug negative 2 back in, 4 times negative 2 is negative 8, plus 2 gives me negative 6, and the absolute value of negative 6 is 6. Okay, so I found the two solutions that when I plug them in, give me the positive and the negative, and when I take the absolute value equals the 6 over here. So since these are just one value, I can write it in brackets, 1, negative 2, or I can just write x equals 1 and x equals negative 2. Either way is fine. All right, looking at my second problem, same thing. Negative 2x plus 7 equals 9. And negative 2x plus 7 equals a negative 9. All right, so when I go ahead and solve the first one, I have negative 2x, subtract 7 on both sides. Divide, and I get x is equal to negative 1. Negative 2x equals negative 16. X is equal to 8. And if I do a quick check, both of them do work out. So my solutions are negative 1 and 8. Excuse me. Now, if you notice, the third problem has a star next to it. Before even solving it, I know that there is no solution. Okay. Now, if I wasn't sure, I could set up my two equations and solve, and when I check both the numbers, they aren't going to work. Why? Well, taking a look at it, no matter what I plug in here for x, no matter what number I plug in, I'm going to get a positive value on this side. Okay, if I multiply 5 by anything and subtract 1, even if I got a negative, so let's say I plugged in negative 3, okay, I've got negative 15 minus 1 and negative 16. Well, no matter what, when I take the absolute value, I'm not going to get negative 3. The absolute value of a number is always a positive. We're talking distance, so we're thinking positive terms. So no matter what happens, when I solve that and get an answer, it's not going to work in. So because I have an absolute value that is equal to a negative, I know it cannot work because I cannot take the absolute value of something and get a negative. All right, now sometimes we have equations that are a little bit more involved. So you'll notice in these examples, that I have a coefficient in front of our absolute value, I have numbers being added or subtracted. So before we can rewrite our two equations, rewrite as a compound statement, I need to isolate the absolute value first. I need to undo any addition or subtraction and undo any multiplication so that my absolute value is isolated. Then I can write my two equations and then I can solve them. All right, so I'm going to start here by adding 7 to both sides. So when I add 7, I get 18. Now I can divide both sides by 3. So the absolute value of x plus 2 equals 6. Well, now that my absolute value is isolated, meaning there's nothing being added or subtracted outside the absolute value, nothing being multiplied or divided outside the absolute value, I can go ahead and set up my two equations. So I've got x plus 2 is equal to 6. I've got x plus 2 is equal to negative 6. When I solve, I have x is equal to 4, or x is equal to negative 8. All right, and I could go ahead and plug those back in to check, and they will both work. So I have 4 and negative 8. All right, the next one, negative 2 times the absolute value of x minus 3 plus 7 is equal to negative 19. So same thing, start by isolating. I'm going to subtract both sides by 7, and I get negative 26. Divide both sides by negative 2, and I get 13. So now I set up my two equations, and I'm going to add 3 to both sides. So I get 16 and negative 10. And once again, when you check them, they work. And I know they actually work, so make sure you're actually checking them. All right, 2 more examples. 5 times the absolute value of x equals 25. So if I start by dividing both sides by 5, get the absolute value of x is equal to 5. So x equals 5, x equals negative 5. And I'm done. All right, my next one, there's nothing to isolate. I just have the absolute value of x plus 4 equals 6. So x plus 4 equals 6. X plus 4 equals negative 6. So x is equal to 2, and x is equal to negative 10. All right. Now let's talk about inequalities, okay? We're going to use the same exact process to do the solving. We just got to make sure our setup is okay. So let's first figure this out. We're going to use the whole concept of our compound inequalities when it comes to shading. So the absolute value expression less or less than some positive value. All right, so if I have the absolute value of ax plus b is less than c. So when this is a less or a less than, that is going to be an and statement. And we talked about this. When it's an and statement, you are shading in between. Remember, the n is in between the a and the d. All right, so when it's the original problem isn't less than, we are shading in between. Okay? So the inequality, the absolute value of ax plus b is less than c, or c is greater than 0, means that it is between negative c and c. All right, which is also equivalent to this statement. I can have ax plus b is less than c. Right, now remember, just like an equation, I need to set up two different problems. So the first one always stays the same. And this is after, guys, your absolute value is isolated. Okay, and then I have ax plus b. We negate the other side, and we also flip the inequality. Super important to remember. Flip and negate for an inequality. For an equation, you're just negating because we're not going to flip the equation sign. You can, just make sure you do 180 and you're back to where you started. Now remember, since this is an and, it's a compound. So really, I'm saying this. Because that's what happens with an and. We have our sandwich inequality in there. All right, so when I have a less than, it ends up being an and. The shading happens in between. All right, when it's a greater than, it's an or statement. And when we have an or, It's like the two oars on a boat. Our shading is happening in the opposite direction. Okay, so the inequality ax plus b is greater than c. It means that it's shaded outside the negative c and c, meaning it's shading going in the opposite directions. All right, now we can't write we can't write a compound statement for this. An or can't. They have to be two separate inequalities. So it looks like this. All right, another way to write it so it's looking all the same. We have the ax plus b is greater than c. That's what this one right here is saying. Or we have the ax plus b flip and negate. Okay. And then we would solve them both and we would graph our inequalities as our answer. All right, super important to make sure you isolate that absolute value first. So taking a look at this, I've got a less than. A less than is an and. Okay, this is an and. Now, this right here is my original one. 2x minus 3 is less than 3. Okay, if you notice, it's the same. There's always going to be one that looks just like the original problem minus your absolute value signs. Okay, the one on the left side is the one where it flipped. How do I know? Because of my negative. All right, so 2x minus 3 is greater than. Negate and flip. And now we just solve them. So I have 2x is greater than 0. X is greater than 0. And 2x is less than 6. So therefore x is less than 3. So when I look at my number line, I've got x is greater than 0. I've got x is less than 3. And so I'm shading in between. And I can write my inequality. When it's an and, remember you can write one inequality. Okay, looking at my next one, it's a greater than, therefore it's an or. Okay, same thing over here is my original because it's the plain old 5. And I have less than or equal to negative 5. So we'll go ahead and we'll solve them both. So I have 2x is less than or equal to negative 12, or x is less than or equal to negative 6. 2x is greater than or equal to negative 2. X is greater than or equal to negative 1. So when I put it on my number line, I've got negative 6, closed, shade left. I've got negative 1, closed, shade right. And it's an or, so I can just put an or in between the two. I don't need to write, or I can't write it as one inequality. All right, taking a look at these. If you want to pause the video and try it on your own and then come back and check your answers, it might be a good thing to do. All right, make sure first that you go ahead and isolate that absolute value. Now that it's isolated, I can go ahead and set it up. Oh, noticing that it's a less than, so it's going to be an and. So 4x is greater or less than or equal to 16. 4x is greater than or equal to 16. So I have x is less than or equal to 4, and x is greater than or equal to 4. Oops, sorry. When I flipped it, I forgot my negative sign. That doesn't make sense. All right, so I shade. It's an and, shading in between. And I can write one inequality symbol. Over here, it's greater than, so it's an or. Can I isolate the absolute value of x plus 5 is greater than 7? So x plus 5 is greater than 7. X plus 5 is less than negative 7. So x is greater than 2. X is less than negative 12. Okay, it's an or. So negative 12, less than 2, greater than. All right, looking at this one. The absolute value of 6x plus 1 is less than negative 11. There is no solution. Why? Think about it. No matter what number I plug in here, I'm going to get a positive. Okay, whatever it is, I'm going to get a positive. There is no way that a positive number can be less than a negative number. It is not possible. Okay, we looked at it with an equation. When it's equal to a negative, it automatically means no solution. Once again, this is after you isolate that absolute value. You got to be careful in an inequality though. You can't automatically assume no solution because I could flip that sign around and have this. Once again, no matter what I get here, I'm going to get a positive number. And is this true? Is a positive number always going to be bigger than negative 11? Yes. So in this case, it will work. And my solution would be all real numbers because no matter what number I plug in there, I'm going to get a positive absolute value, which is going to be bigger than a negative. So please be careful on your inequalities. Don't assume no solution. If an absolute value is less than a negative, it's no solution. If your absolute value is greater than a negative, you do have a solution. It's all real numbers, every solution. All right, the last thing we're going to do in this lesson is we are going to learn how to write absolute value equations and inequalities. So now we're beginning the graph and we're working backwards to write the original problem, kind of like we're on Jeopardy. All right, the pattern remains the same whether it's an equation or an inequality. When it's an inequality, you just got to figure out which symbol you're working with. Okay, so there's two things we need to figure out. We need to find the center or the midpoint between our 2 points or end values. And then we also need to find the distance from the center to either endpoint. So taking a look at this graph right here, my endpoints are -5 and 5. So to find the midpoint, I can just add my two values together and divide by 2. So in this case, I get 0. So my C, or my midpoint, is at 0. Okay, now the distance is going to be the distance from that midpoint to the end. So in this case, it will be from 0 to 5, which is 5. Or you could do it this way too, from 0 to -5. It doesn't matter. It should be the same value in either direction. So now when I plug that in, my answer is just this. X minus 0, okay, 0 is the center, is equal to the distance. Now we're never going to write x minus 0, so that can just be the absolute value of x is equal to 5. So when the center is 0, we kind of just have our x in there. Okay, let's look at this example. We're going from -1 to 7. So -1 plus 7 divided by 2 gives us 3. So the center is at 3. All right, the distance is 4 because it's how far it takes to get from 3 to 7. So when I put that into my equation, if my center is at 3, oops, okay, we already have it there, center's at 3. I flung the wrong thing, that's okay. My distance is 4. All right, here's what we get for our equation. The absolute value of x minus 3 is equal to 4. So when you're plugging it in, it's always going to be x minus whatever that number is. If this number happens to be a negative, like if this was a -3, hypothetically, then it changes and just becomes x plus 3. So one way to think about it is whatever the center is, you're putting the opposite sign inside your absolute value, and it's equal to the distance. All right, let's try some examples. So from -2 to 6, add, divide by 2 to get your center. That gives you 2. -2 plus 6 is 4. Divided by 2 is 2. So my center is at 2. So x minus 2, and the distance is 4. Now our next example is an inequality. I can tell because they're shading versus the other examples just had our dots, so therefore it's just an equation. I'm going to do the same exact thing. -1 plus 7 divided by 2, which gives me 3. So x minus 3. The distance is 4. Now I just got to think about my inequality sign. Well, I know it's an equal to because my circles are shaded in, and because it's an outside, it's an or. And we said or is a greater than. Another way to think about it is if you're looking at this solution right here, always compare it to the bigger number, the bigger dot. Where's the shading happening compared to this dot? It's greater than. Okay. Next example, both are inequalities. -10 plus 8 divided by 2 gives me -1. So my center's at -1. So that means it's going to be x plus 1 inside. It's going to be a less than because it's an and, because the shading's in between and it's not equal to. And the distance from -1 to 8 is 9. All right, my next problem, 4 plus 18 divided by 2 gives me 11. So I have x minus 11. It's going to be a greater than because it's shaded out, so it's an or. The distance is 7. All right, we've got 2 more examples here, okay? This one right here, 13 plus 16 divided by 2 gives me 29 over 2. Keep it as a fraction for right now, and we'll come back to that. Less than or equal to, and the midpoint's at 3. I'm sorry, the distance is 3/2. Now, most likely not going to see a fraction inside your absolute value sign, right? So this would actually be the same thing. If I take my denominator and move it in front, there we go. Okay, so if you get a fraction for your midpoint, just take the denominator once again and make it the coefficient of the x inside your absolute value, and you're good to go. Not much we can do about our decimal or fraction. As a distance, that's okay. It's just inside your absolute value. And my last one, notice this is an equal sign because there's no shading. So to find the midpoint, I have 15 plus 33 divided by 2. 48 divided by 2 is 24, so x minus 24. And then my distance is 9. All right, and that is it for our lesson today. Please come and bring questions to me.